Hey guys, Mr. Backerberg here. In this video, we're going to look at the inverse cosine and the inverse tangent functions. So as we're defining the inverse cosine function, we've got the unique angle y in the interval from 0 to pi, such that the cosine of y is equal to x. We call that our inverse cosine or our arc cosine of x. Now, just like with a sine graph, we had to restrict down the domain in order for the inverse to exist. The same thing is true for the cosine graph, because if we were looking at this graph, right now, it does not pass the horizontal line test, so we would say that it doesn't have an inverse. But what we can do is we can restrict down what portion of the graph we're actually seeing. And we're going to restrict this graph down to being between 0 and pi, because if we're looking just between those x values, then our graph will pass the horizontal line test. So that's what allows us to create this inverse cosine function. Now for the domain of our inverse cosine is going to be some number between -1 and +1. And for the range, our answer is going to be some angle between 0 and pi. And because we're looking between 0 and pi, if we think about things in terms of the unit circle, 0 is on the far right-hand side, pi is on the far left-hand side. So if we think about angles between 0 and pi, then we're really looking at the top half of our unit circle. Now, as we're looking at the inverse tangent function, the unique angle y in the interval from -pi/2 to +pi/2, such that the tangent of y is equal to x, is the inverse tangent or the arctangent of x. Now, just like we did with the inverse sine and the inverse cosine, we're only going to look at certain portions of the tangent graph in order for the inverse to exist. And what we're going to focus on is this set of asymptotes in the middle between -pi/2 and +pi/2. If we only look at that chunk of our graph, then it will always pass the horizontal line test. Now, the domain of an inverse tangent function is going to be any real number. So we can say the domain goes from -infinity up to +infinity. So we can evaluate the inverse tangent for any number we want. The range, or our answers, it's going to be some angle between -pi/2 and +pi/2. Now, because we're talking about angles between -pi/2 and +pi/2, a lot like we talked about with the inverse sine, pi/2 goes from 0 up to that first quadrant angle. -pi/2 would start at 0 and go down to that quadrant angle. So we're going to be looking at the right half of our unit circle as we're evaluating these inverse tangent functions. So let's say I wanted to evaluate the inverse cosine of 1/2. Now, as we're looking at our unit circle, cosine is the x value, and we said we were going to look at the top half of our unit circle when we're doing the inverse cosine. So we're looking for an x value of 1/2 on the top of our unit circle. So I see that x value of 1/2 right here, and that's the angle pi/3. So the inverse cosine of 1/2 is pi/3. Or if I wanted to do the arc cosine of -√3/2. -√3/2 is going to be on the left-hand side. I need that x value of -√3/2, so I'm looking right here. The angle is 5pi/6. So the arc cosine of -√3/2 is 5pi/6. Now, tangents are a little bit trickier. If I wanted to do the inverse tangent of the square root of 3, we have to remember that tangent fractions are made by looking at y/x. So I'm going to take a look at the square root of 3, and I'm going to turn it into a fraction by putting it over 1. Now, here's what I'm looking at. My y value needs to have a √3 in it, and my x value needs to have a 1 in it. So I'm looking on my unit circle, and we're looking on the right-hand side of our unit circle for a y value that has a √3 in it and an x value that has a 1 in it. So I'm looking up at the top here at this pi/3 angle. My y value has a √3 in it, and my x value has a 1 in it. So the inverse tangent of √3 is pi/3. Now, if I wanted to do the arctangent of -1. Now, as I'm thinking about this y/x fraction, in order to get 1 as an answer, my x and y would have to be exactly the same. But since I'm getting -1, one of those values is going to have to be negative. So I'm looking on the bottom of my unit circle on the right-hand side, and I'm looking at the angle 7pi/4. Now, 7pi/4 is too big to fit in our range for our function because we said that it had to be between -pi/2 and +pi/2. So I can think about taking that 7pi/4 and adjusting it by subtracting off a 2 pi rotation. Now we would have to get common denominators in here. 2 pi is the same as 8 pi over 4. So if I take 7 pi over 4 minus 8 pi over 4, the angle I get is negative pi over 4. I can also think about this angle of 7 pi over 4 as being down pi over 4 from 0, so also negative pi over 4 that way as well. That's going to be it for this video. Thanks for watching.